An unsaturated fat is a fat or fatty acid in which there is at least one double bond within the fatty acid chain. A fatty acid chain is monounsaturated if it contains one double bond, and polyunsaturated if it contains more than one double bond. Where double bonds are formed, hydrogen atoms are eliminated. Thus, a saturated fat has no double bonds, has the maximum number of hydrogens bonded to the carbons, and therefore is saturated with hydrogen atoms. In cellular metabolism, unsaturated fat molecules contain somewhat less energy than an equivalent amount of saturated fat. The greater the degree of unsaturation in a fatty acid, the more vulnerable it is to lipid peroxidation. Antioxidants can protect unsaturated fat from lipid peroxidation. Chemistry and nutrition. Double bonds may be in either a si or a trans isomer, depending on the geometry of the double bond. In the si isomer, hydrogen atoms are on the same side of the double bond, whereas, in the trans isomer, they are on opposite sides. Saturated fats are popular with manufacturers of processed foods because they are less vulnerable to rancidity and are, in general, more solid at room temperature than unsaturated fats. Unsaturated chains have a lower melting point, hence increasing fluidity of the cell membranes. Although both monounsaturated and polyunsaturated fats can replace saturated fat in the diet, trans-unsaturated fats should be avoided. Replacing saturated fats with unsaturated fats helps to lower levels of total cholesterol and LDL cholesterol in the blood. Trans-unsaturated fats are particularly risky because the double bond stereochemistry allows the fat molecules to assume a linear conformation, which leads to efficient packing. The geometry of the si double bond introduces a bend in the molecule, thereby precluding stable formations. Natural sources of fatty acids are rich in the si isomer. Although polyunsaturated fats are protective against cardiac arrhythmias, a study of postmenopausal women with a relatively low fat intake showed that polyunsaturated fat is positively associated with progression of coronary atherosclerosis, whereas monounsaturated fat is not. This probably is an indication of the greater vulnerability of polyunsaturated fats to lipid peroxidation, against which vitamin A has been shown to be protective. Examples of unsaturated fats are palmitoleic acid, oleic acid, myristoleic acid, linoleic acid, and arachidonic acid. Foods containing unsaturated fats include avocado, nuts, and vegetable oils such as canola and olive oils. Meat products contain both saturated and unsaturated fats. Although unsaturated fats are conventionally regarded as healthier than saturated fats, the United States Food and Drug Administration recommendation stated that the amount of unsaturated fat consumed should not exceed 30% of one's daily caloric intake. Most foods contain both unsaturated and saturated fats. Marketers advertise only one or the other, depending on which one makes up the majority. Thus, various unsaturated fat vegetable oils, such as olive oils, also contain saturated fat. In chemical analysis, fatty acids are separated by gas chromatography of methyl esters. Additionally, a separation of unsaturated isomers is possible by argentation thin layer chromatography. Role of dietary fats in insulin resistance. Incidence of insulin resistance is lowered with diets higher in monounsaturated fats, while the opposite is true for diets high in polyunsaturated fats as well as saturated fats. These ratios can be indexed in the phospholipids of human skeletal muscle and in other tissues as well. This relationship between dietary fats and insulin resistance is presumed secondary to the relationship between insulin resistance and inflammation, which is partially modulated by dietary fat ratios with both omega-3 and 9 thought to be anti-inflammatory, and omega-6 pro-inflammatory. Although both pro-inflammatory and anti-inflammatory types of fat are biologically necessary, fat dietary ratios in most U.S. diets are skewed towards omega-6, with subsequent disinhibition of inflammation and potentiation of insulin resistance. But this is contrary to the suggestion of more recent studies, in which polyunsaturated fats are shown as protective against insulin resistance. Membrane composition is a metabolic pacemaker. Studies on the cell membranes of mammals and reptiles discovered that mammalian cell membranes are composed of a higher proportion of polyunsaturated fatty acids, DHA, omega-3 fatty acid, than reptiles. Studies on bird fatty acid composition have noted similar proportions to mammals but with January 3 less omega-3 fatty acids as compared to omega-6 for a given body size. This fatty acid composition results in a more fluid cell membrane but also one that is leakier to various ions, resulting in cell membranes that are more costly to maintain. This maintenance cost has been argued to be one of the key causes for the high metabolic rates and concomitant warm-bloodedness of mammals and birds. However, polyunsaturation of cell membranes may also occur in response to chronic cold temperatures as well. In fish, increasingly cold environments lead to increasingly high cell membrane content of both monounsaturated and polyunsaturated fatty acids, to maintain greater membrane fluidity at the lower temperatures. References. See also, saturated fat, list of unsaturated fatty acids, monounsaturated fat, polyunsaturated fat, trans fat, iodine number. A chemical analysis method to determine the proportion of unsaturated fat.